get going. Again, welcome today. Going to have a good topic at the RWG session today, looking at validating the readiness of potential requirements. We have Dr. Ron Carson, a INCOSE fellow and ESEP, presenting today. He's currently a course facilitator for the Certification Training International, training experience and aspiring system engineers to pass the INCOSE System Engineering Professional Certification Examination. Dr. Carson also maintains a YouTube channel, Ron on Requirements, with presentations of his papers on system requirement analysis, architecting and model-based system engineering, and system engineering measurement. From education perspective, Dr. Carson has a PhD from University of Washington in nuclear engineering and a BS from California Institute of Technology and Applied Physics. Work history, Dr. Carson retired as a tech fellow from Boeing after system engineering 27 years within the Boeing company, worked on a variety of projects, commercial airplanes, satellite communication, mobile platforms, and various defense systems. He's been an adjunct professor in engineering at Seattle Pacific University and system design, the University of Washington in system architecture and model-based system engineering, and the Missouri University of Science and Technology in system engineering management. He's the author of numerous articles regarding requirements analysis and system engineering measurement, and is the developer of numerous industry system engineering training courses. He's been issued 6 U.S. patents in satellite communications and 2 patents regarding structure requirements, generation, and assessment. And with that, I will hand it over to you, Dr. Carson.
Okay, thank you, Kevin. It's good to be back. Uh, so I thought I was done working on requirements, and then some questions popped up from the Adaptable Systems Working Group. So I'm going to go through some of what we've learned over the last few months in developing, and maybe give you folks some action items to think about pursuing in this area. So what I want to cover is, why am I doing this? What's behind it? I'm going to rehearse a little bit about some things that we've been talking about for 30 years, because I thought we were all done with talking about what is a requirement, but turns out it's not so. Talk about validation and what we mean by validated requirements. And then I'll get into some new stuff that I just started working on about uncertain and potential requirements and what we mean by adaptable requirements development. And then we've proposed a requirements readiness level to help us assess how good are our requirements, not just in the content and how it's written, but in terms of some of the other validation criteria. I'll be referencing a lot of INCOSE papers, mostly my own, but a couple others. And all my presentations are available on my YouTube channel. And I'm hoping to link this one after I get a link to the recording. So you can go back and look at some stuff if you're interested and don't want to read the papers out of the library. You can just watch the presentations. So why are we doing this? Well, I started having some discussions in November, October last year with the Adaptable Systems Engineering Working Group, and made an initial presentation talking about adaptable requirements development. I thought we'd sort of put the issue of what is a requirement to bed some 20 or 30 years ago, but not quite so. So some statements are called requirements, but they're not. They're not mandatory. They're not a basis for acceptance. Sometimes there is just a wish list. We had a large discussion in Requirements Working Group circa 2000. Thought we got that dealt with in the requirements completeness paper, which is a joint activity for members of this group. But it continues to raise its ugly head about what does really a requirement mean. This presentation goes beyond some prior work in looking at what we are calling a requirement readiness level. And a new paper was just published last 2 months in IEEE by Haifeng Zhu, myself, and Ray Barton of the Adaptable Systems Engineering Working Group. Why do we think this RRL might be useful? Well, when we took a quick look at existing requirements maturity measures, they're mostly about requirements management and process maturity, a la the CMMI, but not measuring the actual content of the requirements. And those have been following my papers for a while. That's what I worry about, is what does a requirement actually say? The 2015 paper looked at the structural content. The paper in 2018 with Bob Noel of Boeing, we looked at whether the content itself is right. And that prior work in 2018, we had 4 measurable attributes, but 2 of them were binary. And the latest paper we published proposes changing that binary assessment to another graded scale. And so I'm going to talk through all that. What is a requirement? This is a slide I think I originally put together for the 2004 paper. A requirement is a mandatory provision, and Rick Harwell, who was the leader of this requirement management working group back in 1993, was it what it was called, came up with a nice description. If it mandates that something must be accomplished, transformed, produced, provided, it is a requirement, period. The key is mandate, mandatory. So, and that's consistent with the dictionary definition. So that means it's not a design description, it's not a goal, it's not a desire, it's not a feature. And in my mind, a tradable requirement is an oxymoron. And confusion arises if we don't insist on the concept of mandatory. And in the 2004 paper, it made the point that you can't assess completeness if you don't use that concept, because there's no end of desires and goals and so forth. So, what should we do if we're not sure it's mandatory? This is a situation projects find themselves in. They're not sure if they should make something mandatory. And can we still do validation on it? In particular, can it be scored other than binary for necessity? So hang on to those thoughts and we'll get into it. Well, why do we have requirements? Because they seem to create lots of issues. Of course they do, but they are a technical contract, part of any acquirer-supplier relationship, because they define the expectations, more particularly the acceptance criteria for the solution, but that's if and only if it's actually mandatory. They do and should provide a verifiable means to ensure that the as-delivered system or its elements satisfies the technical contract. The absence of requirements means there's really no objective basis for evaluation and assessment other than user and stakeholder feedback about what they like or don't like or wish you had, which is the essence of agile methods. And these may actually introduce the concept of a requirement with a label called test-driven development, which is a requirement by another label because that defines upfront the success criteria for whatever the solution is. In my mind, agile methods regarding requirements are risky for other than time and materials contracts because you really don't know what the satisfactory end state will be when you start. I covered some of this in the 2013 paper, Can Systems Engineering Be Agile? If you want to look at that, and there's a video on my YouTube channel about that. So the issue before us, if the acquirer is unsure of what they actually need, that is the requirements, or if they're open to a range of solutions based on perceived value, how should they proceed with this whole issue of requirements? We did a paper in 2018 on validation using handbook definitions. This is from the 5th edition. The validation process provides objective evidence to confirm the right artifact or entity has been made according to the stakeholder needs and stakeholder requirements. So it's not just that it's stated properly, but it actually addresses the true needs of the stakeholders. That means we have defined behaviors and associated characteristics, that is, requirements that are correct and complete, and that's language out of the commercial aviation standard, ARP 4754A. Nothing is missing, Nothing extra is included. Everything is correct. So these are type 1 and type 2 errors, and these become the acceptance criteria for the system. We decomposed that into validated and verified requirement subjects. Validated meaning satisfy stakeholder needs and there's no unnecessary requirements, and verified meaning they satisfy the parent requirements and conform to standards for requirements. We synthesize that to come up with correct set of correct requirements and 4 validation criteria. This is all elaborated in the 2018 paper, which is available on the YouTube channel as well. So we start from stakeholder measures of effectiveness, how stakeholders measure success, and function and mission needs, the minimum capabilities required, the mandatory characteristics. And going beyond that, goals, desires, objectives can be handled as value propositions. And I'll show you a slide later on that. And also no unnecessary requirements because they over-constrain the solution and lead to excess program cost. Correct and complete requirements can be assessed for correctness and completeness. And really, completeness is a form of correctness. That's the type 2 error. Our 4 criteria are verifiable, sufficiently clear and complete to be able to prove that it is needed, satisfied, and feasible, the other characteristics. And this was the focus of the 2015 paper on requirements quality. Necessary, and this is the key issue for potential requirements, the parent requirement or need cannot be satisfied without this requirement. And I always told people, well, if you're not sure if it's necessary, try and delete it and see who screams. And that's an easy way to check. Sufficiency is referred to with the phrase completeness, in part in the INCOSE handbook, Guide to Writing Requirements. But the key is if this requirement is satisfied as stated, then the parent requirement or need will be satisfied deterministically. In other words, there's a tight coupling and clear deterministic connection between the child requirement we're trying to assess for sufficiency and the parent requirement or need. That may need to be assessed over the whole set of requirements we come up with, because if I'm missing a requirement, in other words, there's some stakeholder requirement that is not being addressed, there's no requirement for me to assess as regarding insufficiency. So Lou Wheatcraft pointed this out at the session last week. So that might be some additional assessment we have to do to go looking for childless parents. The last criterion is the feasibility criterion, that the requirement can be satisfied within the program constraints with acceptable risk. And so that's a risk assessment, and that's how we measure that one. We've asserted that these characteristics are disjoint, concise, and complete, necessary and sufficient to determine that the set of requirements is correct and complete. And you're probably all familiar with the existing handbook and guide to writing requirements have 15 characteristics, 9 for individual requirements that are acknowledged not to be disjoint, and then 6 additional characteristics over the set of requirements. Measurable characteristics, well, if we construct a Venn diagram of our 4 characteristics, then we can easily see that a requirement cannot be correct if it's is only correct if it's feasible and necessary and sufficient and verifiable, and it can't be correct if it's missing any one of those, which is what we talked about and how to get there in the 2018 paper. Our measure scales, verifiability is a quality assessment based on the structure, which we elaborated in the 2015 paper. We used a scale of 0 to 4. We found that very useful in training and implementation because it can mimic a grading scale from academia. Our newer work renormalizes that to be a 0 to 1. I'll take questions at the end, so hold those questions and we can talk about things at the end of the presentation. Necessity is binary, This was in the 2018 paper. It's either necessary or not. There was no middle ground. Similarly, sufficiency was also binary. So we didn't have a way to assess or didn't want to assess, for example, it's got all the right functionality and conditions, but the performance is just a little bit shy of the stakeholder requirement. Well, then it's not sufficient. It was very cut and dried in my mind. The last measurement is on feasibility. That's really a risk assessment. If it's infeasible, that's a 0, then it's an issue. You're going to have to fix something because it's not feasible. If it's a 1, then it's either low or no risk. I hesitate to say anything's no risk. But that means you probably have a TRL 9 kind of solution that has already been, something's already been built that meets the requirements in those conditions. So what do we do with, given all this, what do we do about potential requirements? So that's a new word. So I thought, well, let me take advantage of the latest online technology. So last November, I asked Google Gemini a couple questions. This one was what is meant by uncertain versus potential requirements. And I put the date in here just because my understanding of these tools, if you ask the identical question now, you might get a different answer. But this seems kind of like a sensible answer. For uncertain requirements, there's a lack of clarity. And we're not sure what's being asked. They said it's like a blurry photo. You know what it is, but you need to focus it. And my insertion is, well, you think you know what it is. So we can sometimes get fooled by a degree of uncertainty. Potential requirements, key idea, lack of a confirmed need. Right. That fits with that word. So the action is to monitor and decide whether to make it a confirmed or what I would call a validated requirement with whomever is the associated stakeholder for that potential requirement. So that fits pretty well. So if I put these things together, I have what I call here a taxonomy of requirements for adaptable development. So requirements truly are mandatory characteristics, and they are validated as verifiable, necessary, sufficient, and feasible. Uncertain requirements may not be verifiable, and if they're not verifiable, we may not be able to assess necessity, sufficiency, or feasibility, and therefore we need to evaluate and improve on all the validation criteria. Potential requirements really should be verifiable and sufficient and feasible, but we're just not sure about necessity with respect to some potential mission or performance attribute. The process of validation moves us from these two subsets into a set of validated requirements. And that's the new thing we started working on last fall. So I asked Google Gemini at the same time what is meant by adaptable requirements development because I got invited to participate in the Adaptable Systems Engineering Working Group and I didn't know anything about it. So I thought I'd go to some online sources. So adaptable requirements development, an approach to defining and managing project requirements that prioritizes flexibility, continuous learning, and responsiveness to change. And if you've read the INCOSE handbook, that just starts sounding familiar to another phrase that's used in there. It recognizes that in complex or dynamic environments, particularly in software development, where is often referred to as adaptive software development or a core aspect of agile methodologies, which is the term that's used in the INCOSE handbook. Requirements are likely to change as the project progresses, stakeholders provide feedback, and new information emerges. Well, we've seen this before in the INCOSE SE handbook under the approach of evolutionary development. We don't know all the requirements when we begin, so it's not waterfall or incremental. It's an evolutionary development approach where we have some idea of where we're starting from. We build it, deploy it, and learn, get feedback, and then do this again. So it's this cyclic action of putting something out there and then seeing how well our stakeholders like it. And I commented on the agile development process back in 2013. And one of the things I noted was the technical processes that I've listed here are really, for the most part, finish to finish. In other words, you don't really have to have requirements if what you find you've built and integrated is acceptable to the stakeholders, unless you have to prove some sort of verification. But otherwise, it's all finish to finish, and the only sequence is this build to integrate. And I can do the rest of the documentation after the fact, and that's keeping with the Agile manifesto of valuing finished product over documentation. There's reasons that we highlighted in this paper, while this is a little bit more troublesome for other kinds of development, but it works fine in evolutionary development, especially with software. So what does this look like then for adaptable requirements development process? Can we use the technical processes in the INCOSE handbook? Well, collect the stakeholder needs. That's in technical processes .1 and .2, which follow the 15288. Then we refine, deconflict, prioritize the needs into stakeholder requirements. That's the .2. Validate a subset for initial implementation, and that's when we move some of the stakeholder requirements into system requirements. Then we go through the rest of the V chart: architect, design, implement, integrate, verify, and validate, sections 4 to 11. We can apply adaptability architecture metrics for the architecture selection. Got a slide coming up on that. But when we're done through our degree of validation, and this can happen very quickly, especially it does in software development sometimes, we can revisit the stakeholder needs and look for gaps based on feedback from the users, the other stakeholders, or known gaps because we didn't put everything into the first tranche of system requirements. Then we can validate additional requirements, add them to the baseline, repeat the cycle, and go merrily on our way. So, characteristics of this: it's controlled change using configuration management. And we have a traceability of the source of the change based on feedback, revised stakeholder needs, or decision to add a requirement into the baseline at some point. This works, in my mind, really well for time and materials contracting, a multi-cycle kind of activity. Or, as was pointed out to me, it could be used for a fixed price for individual cycles. Once I have a agreed upon set of system requirements for any iteration, then I can go through the rest of the process and deliver, and then come up with another cycle, another contract if I want to add more requirements. So extending the validation for adaptable requirements means I have to now go back and evaluate my missions and requirements evaluation space. So this is a term that was in Haifeng Zhu's paper from 2016 and is reconstituted here in the recent paper, IEEE SysCon, earlier this spring. We capture the current and future potential needs in the system and mission requirements, and some of those will become validated requirements, but we recognize there's likely incompleteness of the associated requirements that affects verifiability. In other words, how it's worded. We may be missing information, for example, in the requirement statements. The sufficiency of the functions to address all of the missions that are being considered, and their associated performance measures, the quantification of that functionality, and possibly the related conditions of performance of some of those functions or missions, because we're extending what the system does into conditions that we hadn't first thought of, like we go from airborne to undersea or something with some capability. There's an inherent lack of necessity, at least formalized, until the potential requirements become required. And I dislike required requirements as a phrase, so I think I'm willing to live with validated requirements, but other adjectives just make me nervous. And it seems that the absence of a prefix adjective leaves ambiguity about what the current validation state of a requirement is. So we may have to go with validated requirements to mean that, yes, we satisfy all of these four validation characteristics or all 15 characteristics in the INCOSE guide. We did do some work back in 2013 on system engineering measurement, architecture measurement. We did have a scalable measure related to suitability, called adaptability, which is basically a way to try and measure how well some characteristic of a requirement satisfies not necessarily a requirement, but some desirable feature of a proposed or potential architecture. Some of these measures can actually be used with respect to requirements for a value proposition where we can measure performance above threshold as a way of being able to take advantage of perhaps additional capability. But a number of these things we recognize were desirable, but it's hard to write requirements for things like simplicity or modularity. So it's sometimes easier just to do this kind of a suitability attribute. But we did have a way to measure this on a scale of 0 to 1, which is exactly how Haifeng Zhu did it in his 2016 INCOSE paper. And we can also do this for performance attributes. So I think we're pretty much aligned there with the idea of scalable measures. But if I go back and look at the 2018 paper, our scoring framework was binary in necessity and sufficiency. It was either necessary and sufficient or it's not, as I previously explained. It was scaled in verifiability, 0 to 4, like our letter grade scale, or in feasibility, going from 0 for an issue to 1 for low or no risk. Our recent paper, we decided to modify based on feedback, necessity and sufficiency scales to also be scaled from 0 to 1. So verifiability is still a scaled attribute. Our original paper was 0 to 4. In the current work, we renormalize it so it can go 0 to 1 and be like all the other scales. So that's pretty straightforward. Went through a lot of detail in that in the 2015 paper and the associated patents. Sufficiency. Now, if it's going to be 0 to 1 for each requirement, then we have to develop detailed criteria for what that means. And I'm making the observation that if verifiability is less than 1, then sufficiency really can't be greater than verifiability because there's some ambiguity in the verifiability, which means how can you know if the child requirement is sufficient versus the need if it's not truly a verifiable requirement. So this is an area that we'll need to explore some more. But over a set of requirements, just like verifiability, we add up the scores for individual requirements, normalized by the total number of requirements we're evaluating to come up with a set score. Necessity, similar to sufficiency in that it's now going to be scaled from 0 to 1. N equals 1 means it's determined to be necessary, so it moves from potential to validated. But we still need detailed criteria for anything n less than 1. This could be, for example, a probability that the requirement will become necessary at some point, but I don't have any details on these two scaled criteria, so that's going to be my proposal for future work for the working groups. Lastly, feasibility has always been a 0 to 1 scaling, same sort of set-based measure, but it's analyzed as risk. 0 is infeasible, which means it's an issue and you have to fix something because it can't be done. And 1 is, I'll put no risk in quotes, and please don't argue with me about nothing in the future is no risk, because I agree, but I hope you get the idea about what 1 means. In our recent paper, so we had a summary table about requirements readiness level, and levels were associated with where do you need to be at the different stage of a project. So we emphasize that the requirement needs to be verifiable just so you can evaluate the other criteria. So anything less than 100% over the set was deemed, well, you're not ready to go. Once they're all verifiable, then you can start examining other things. In the concept stage, look at sufficiency with respect to the parent need or requirement. Look at necessity as part of the acquire-supplier relationship development. It was pointed out to me by Haifeng Zhu that sometimes, because of the value proposition, potential requirements can move from potential to being validated and part of the contract based on the value proposition and the assessment from uh, bids from acquirers, from suppliers. That is, acquirer leaves open the possibility that some capability may be desirable and lets the suppliers bid on that. But at some point, if you go on a contract, especially for firm fixed price, you really do want all these things to be fully verified, verifiable, sufficient, necessary, and feasible to mitigate the risk. So requirement has to be verifiable before you can make conclusions about other criteria. Sufficiency can be assessed versus a need or parent requirement as the need evolves. Necessity has to transition to one to make the requirement go from potential to firm, and feasibility should be continuously assessed as risk in conjunction with the need and throughout development. And I'll just point to a project manager's guide from the System Engineering Measurement Working Group in 2015. Measure number 6, titled Requirements Compliance, is a means to do that assessment. So I thought I'd throw in an example requirement and how I might assess it. So this would be an individual requirement, not totality of a set, but this would be a functional performance requirement. The system shall deliver payload at a destination airport where the airport complies with US FAA Part 139 for Class 1 to R4 airports. So this is about airport capabilities with a payload range performance that's in accordance with a figure, because we know there's always a trade-off in aviation, and airspeed greater than 550 knots while exposed to 99% of natural environments over the continental USA. Now, my disclaimer on this is Ron Carson's rules for requirements is any requirement can be improved. So I recognize some of the deficiencies here, and I'll talk through some of them. Parent or mission need. Why do we have this requirement? Well, somebody wants to do cargo delivery operating over the continental United States. The uncertainties that are here are, well, what are some characteristics of the payload? We know the payload range criteria, which implies a maximum payload of 80,000 kilograms. We're not really sure if that's the right number. But in particular, the description of payload is totally ambiguous. We don't know what size, we don't know what its shape is, we don't know what's in it, maybe hazardous, which means it might preclude shipping, airborne shipping. We're not really sure about the required speed, and maybe ground transport is sufficient. And an important constraint might be the cost per ton mile as a performance attribute associated with this. So it might drive us to a different solution where we don't really need 550 knots, but we might need something a lot lower. So when I assess this, because of the ambiguity and some of the conditions, and particularly the payload, I might give it a 2 out of 4, which normalizes to a 0.5 on a 0 to 1 scale. I would say I'm not sure about the need, so at this point, I just give it a rough 0.5. I don't know how likely this is to turn into a fully validated requirement because I have to do some investigation about a few things. So that's a rough assessment. Sufficiency, if I apply my constraint that sufficiency can't be any higher than verifiability because of uncertain performance and conditions, and that also gets a 0.5. And feasibility. Well, if I take this requirement as described, with the exception of the payload, I can probably do this job with a 757-200 freighter but I'm not sure about the payload fitting. So I might give it something higher, but let me just give it a 0.5 for now. And the advantage of assessing individual requirements with numbers is then I can just add it all up, divide by the total number of possibilities, and I get a requirements readiness level, also a zero point 0.5, which tells me there's a risk of baselining this requirement. So I shouldn't go on contract with this without some risk reduction activity and money. In particular, as far as process is concerned, we really need to come up with some robust measurement scales for necessity and sufficiency. So it's not just me throwing out a number. In other words, what are the objective criteria for making an assessment of necessity of 0.5 versus a 0.6 or a 0.3 or a 0.1? Similarly for sufficiency, even if we have this constraint in place. So that's what I'm going to suggest coming up. So if I do an assessment of where we are, verifiability was published 2015 as a 0 to 4 graded scale. Most of the other measurements I've seen, even if they examine elements of requirements of a structured requirement, there's still a binary assessment. The Boeing process, and those of you that might work at Boeing have access to this, we had clear criteria of what a 1, a 2, a 3, or a 4 meant for each and every element of each and every type of requirement. And we use this color-coded scale, which I first published in 2008, to give the idea of, well, in where you'd really like to be is a B or B plus or above, um, because that seemed to retire most of the risk. Most of the requirements we were seeing were in the 2 to 3 and low twos particularly, or less than 2. Less than 2, that's a failing grade, right? So we thought there was a lot of room for improvement, and the color coding we applied seemed to point people in the right direction about what to fix. So this we had detailed definitions on, but might need to be reconstituted for more public work in detail. Sufficiency. If it's scaled 0 to 1, the question is if the requirement is satisfied, will the parent need a requirement be satisfied, considering completeness of conditions of applicability, like states, triggers, environments, configuration, the completeness of the functions versus the mission needs, the satisfaction of the performance criteria with respect to quantified functionality, timing, tolerances, and necessity. Is this criterion truly required as a condition of acceptability? Some of this is obviously going to be stakeholder dependent, which harkens back to the completeness discussion from 20 years ago, more than 20 years ago. Who are the stakeholders and what do they care about? So you have to circle back in order to establish necessity. This may and likely does relate to a value assessment that, well, if it's cheap enough, I might require it. And therefore, you need some information about what is it going to cost. Feasibility continues to be a risk assessment regarding considering the program constraints and technology. Can we do this on the project with acceptable risk? So, in summary, our potential requirements can be adapted into the development process using our existing system engineering processes, not just the technical processes, but especially configuration management. Changing the requirements paradigm from binary and mandatory to potential complicates the validation activity. And I think graded scales are needed. And I think using these 4 criteria we have, necessity, sufficiency, feasibility, and verifiability, we've already established measurement scales for some of those. When I've looked in the guide to writing requirements, we have 15 characteristics, but there's no measurements discussed as regards them. So that could be used, those could be used. But I think for reasons we published in our 2018 paper, I think our 4 validation criteria are to be preferred with some addressing of the issue of childless parent requirements. In other words, we don't have a requirement we can assess because there's a missing requirement with respect to the stakeholder requirements. Finally, I think this requirements readiness level will be useful. Nobody else was using this, and I thought, well, we got other other readiness levels for technology and manufacturing, and probably a few others by now. So that seems to me this is a means to enable tracking of the requirements development, like technical performance measures and technical readiness level. So I'm going to suggest that this might be something this working group might want to tackle as a project, or do it as a project in concert with the Adaptable Systems Engineering Working Group, since this is an issue about potential requirements and adaptable development. I'm not volunteering to lead that, but I'm more than happy to support it if this is something this requirement working group wants to get behind. So my last slide is here's references that I've cited. All the INCOSE papers are available in the INCOSE presentations and papers library. Videos of my presentations are on my YouTube channel here. Our latest paper was published IEEE SysCon. It's available on the IEEE Explore here. And you all know about the System Engineering Handbook, the ISO 15288, and the Guide to Writing Requirements. And with that, I'd be happy to take questions. Kevin, if you want to referee that, so because you probably have been able to scroll through things as they've come, and I'll be happy to try and answer them.
Sure, can do. Excellent presentation and exciting to have an invite for a possible project. Folks are interested in leading. So I'm going to look at some of the questions in chat, kind of going from the top to bottom. There's 4 or 5 there, and then we'll open it up
Okay.
if folks have other questions. So Ken Curtin asked, what about requirements that are mandatory by an organizational policy or by public law?
Then they obviously are necessary. If you don't have a way of and I don't know how to get around public law or organization policy is a little bit fuzzier. It depends on if it's a mandatory element or it's simply guidance, and that's going to depend on how the organization states a particular characteristic. But yeah, in general, if it's mandated, there's that key word, right, Ken? Mandated, then it's mandatory, and then automatically it's needed if the
Absolutely.
conditions associated with the characteristics of the project or the system of interest are consistent with what the mandatory characteristic is.
Absolutely. I agree with the mandatory process. The real issue comes down to how do you verify it when the way it's stated is basically unverifiable?
Is that because it's ambiguous?
Yeah, it's because it's ambiguous, and most regulations are.
Yes.
And that's one of the realities is when you're putting together verifiable requirements, you are likely at the minimum going to have to go back to your point of contact in the regulatory framework and say, if I meet this requirement, will that satisfy your regulation? And my experience is they'll never commit to that. They'll say, well, I need to wait and see the design. In other words, they don't want to commit themselves up front. I don't have a way around that. So that's one of the sad realities of regulations. They tend to be ambiguously stated, and the regulator point of contact will not commit to any interpretation until they see the solution. If anybody's got an answer for that one, please publish it.
Yeah, it's called accountability.
Yeah, yeah. Okay.
Answered pretty well. But yeah, Jeffrey Walk as the next question is feasibility based on doability versus affordability, which is based on timing and return on investment?
It's, as I said, the way we defined it is that that requirement can be satisfied within the constraints of the program. So that's schedule and budget with acceptable risk. Now, as soon as you introduce that, you create fuzziness, and that's going to be an assessment by the people on the project. Some things that violate the laws of physics, that's clearly not feasible. As regards all that has to do with affordability, it's can you accomplish it within the budget, cost, and schedule with acceptable risk? That's going to be a judgment call. So that's going to put it somewhere less than 1. And if it's other than infeasible, then something greater than 0. So it's like any other risk assessment. So I don't know if I'm answering your question,
Yeah, I
Jeffrey,
think you
but
did.
okay.
I guess I was just getting at some of the fuzziness that's introduced with feasibility because at the end of the day, if it's either you can or can't do it, and then you go on to you can or can't afford it. So a two-step process typically.
Yeah, well, I would want to do both of those at the same time. In other words, if I can't afford it, then I call it not feasible. If I know I can't afford it, if I'm not sure I can't afford it, then there's some risk. So it's something other than a 0 and other than a 1. So,
Yeah.
all right, next one.
From Amika, does an adaptable requirements concept contradict the very definition of requirement as a mandatory need when we are not certain what the need is?
Yes. But apparently, this is a reality that a lot of projects are having to deal with, that things are potential requirements. And so I'm okay as long as we keep that prefix adjective there, that it's labeled as a potential requirement, and then the acquirer has some sort of description or criteria of how it is going to be moved from potential to validated or firm based on value proposition or new information or whatever it is, so that a supplier has some sort of a chance of coming up with solutions that are going to meet the real stakeholder needs and satisfy the acquirer. But yes, I agree. I have always felt that any prefix ahead of requirements fuzzes up the definition of requirement. So I agree with the sentiment, but the reality in our world is now people are talking about this, particularly the Adaptable Systems Engineering Working Group. So I thought, well, let me see what I can come up with that might help move the needle forward, if you will. So yeah, thank you for that question and reinforcing the idea of mandatory. And I will always agree with a requirement is mandatory, but sometimes acquirers aren't sure of what the requirements are. And I really didn't have a means to address that other than, well, if it's not called a requirement, then we don't have to do it. And it didn't get into the whole value proposition issue. So thank you for that question.
Yeah, that was a good one. A couple more from Jeffrey. As systems, increasingly software and agents become more interoperable, how does Agile address significant error, gaps in governance, and unsafe control actions as complexity grows geometrically and after the fact derivation of requirements may prove expensive if not infeasible?
Well, you'd have to ask the Agile Working Group, but this was actually addressed in Bain and Turner's book, 2004, Balancing Agility and Discipline, because sometimes you get to what they call architecture breakers. You add the straw that breaks the camel's back is a phrase we've used in our culture for a long time. This additional requirement here, it's just one little requirement, yeah, but now we're going to have to, quote, refactor the architecture, refactor all the software in order to be able to do that. So yes, that is always a risk in agile methods, that the next thing you add will cause you it is not just an increment, it causes a wholesale change. And this issue that I'm talking about, it's no different from that. That if we try and move something from potential requirement to validated requirement, we need to be able to assess this is the value proposition, right? If I have to completely rework the totality of the architecture, the acquirer may decide that no, that's not worth it because it's too expensive to add that additional capability because of the need to re-architect everything. And that's why you go through the value assessment for potential requirements before they become firm or validated. Does that help, Jeffrey?
Yeah, I think it does. I think the biggest concern is the loss of uh, clear boundary points around
Yeah.
componentry and component design and how they're floating over increasingly. And it's a bleed over effect where we are creating the unknown quadrant is just exploding. And if you put agile in there, you're just creating fuel for the fire. You just don't know how this is going to evolve. And then if you try to come back to the requirements, it's like trying to, it's trying to figure out how the circle of yarn got put together.
Hmm. I agree. Um, my criticisms of Agile are published, so um, but that's the way a lot of organizations are operating. So I'm trying to address the reality of what I see, and that was the challenge from the Adaptable Systems Engineering Working Group. What about potential requirements? I said, it's an oxymoron.
Yeah,
But
yeah,
that wasn't satisfactory, so I'm trying to, move the ball a little bit along, and those of you who are interested can lead and or work on a project like this and maybe come up with some solutions that can help.
yeah.
So people will tell you I was good at pointing out problems when I was at Boeing. So
Mhm.
uh,
One more question from Jeffrey, and I see your hand raised. Lou, we'll get to you in a minute. Is the need to decouple and or decompose a requirement another dimension of the assessment? Or is that an outcome that may be obvious to the stakeholder and or sourcing team for a requirement?
in the process of moving from stakeholder need to stakeholder requirement, there should be refinement to make the stakeholder requirement verifiable. So you know what you're dealing with. So you're disambiguating the need. Excuse me. So you can actually eventually be able to prove whether it's satisfied or not. The ubiquitous, it shall be user friendly. Yeah, everybody has a different idea of what that means. So that's not a requirement. That's a need, but that's not a requirement. That sort of thing. So yes, you almost always have to decompose in the process of disambiguating. You may come up with a dozen requirements for some stated stakeholder need that's ambiguous. And that's not unexpected because stakeholders don't like to get pinned down right away. They just tend to like to describe things sort of loosely and then be able to accept or uh, disagree with your solution when you finally come back with it. This is why refinement and prioritization and decomposition is so important so that we're working to verifiable requirements. That's why that's the first thing. Okay,
Hey,
let's
Lou,
go on.
you have
Oh,
a
yeah.
question or comment?
Yeah, one of the things that we stress in like the needs and requirements manual, guided writing requirements, is needs and requirements, and needs in the sense of not just natural language, communication, but well-formed needs. And so the characteristics in the guided writing requirements apply to the integrated set of needs as well as to the set of design input requirements as we define. And so it seems like a lot of the metrics that you're talking about, we could do to assess the needs and make the determination whether something's really needed before we go through the effort to transform those needs into the set of design input requirements. Because the set of design input requirements communicate what the system must do to meet the baseline set of needs, but the baseline set of needs to be assessed, its quality needs to be assessed against those same characteristics.
Yeah, at any stage where you're formalizing whatever the need is, you can apply the assessment criteria in order to decide whether it's, in this case, really needed. Yeah, I don't disagree with that. I mean, I've disagreed over the formalization of needs, but I think once you formalize the need, that's a stakeholder requirement in my mind. But we can continue to agree to disagree on that. But yes, once you've formalized or restated a perceived need into something that you can actually evaluate, measure, then you can apply these whatever characteristics of a good validation to, whether it's the 15 characteristics in the handbook or our 4 validation criteria.
Thank you.
All right. See if we squeeze a couple more in real quick before the hour. So Isabella asked about the presentation being available. So yes, the presentation and recordings will be available. Sound like various locations. RWG has a YouTube channel it'll be posted on, and sound like Ron will try to get a copy of recordings to him to post on his channel
Yeah.
also.
Thank you.
Next from Ms. Bell. Presentation sounds very conceptual. How do you connect theory to real life when there's nothing of the above happening? No stakeholder need capture formally documented other than meeting minutes or contract scope. Requirements are extracted from design criteria. It sounds like there's not a lot of input on the customer side.
Yeah, well, this is the whole issue of requirements development. Are there really requirements, or the basis for acceptability that the design matches some concept from the acquirer? Because I mean, U.S. Army for decades, that was how they wrote requirements: is give me a solution that looks like this. And the idea of a functional performance requirement was a new thing back in the 90s. So, if they don't know how to do requirements, then you're back to some of the early activity on requirements development. And this is just the top spiral of what you have to be able to handle. But being able to identify the mandatory characteristics is absolutely essential for doing requirements development. And I would always ask clients, hey, if the solution doesn't have this capability, would it still be acceptable? Or this performance level? Or under these conditions, would it still be acceptable? And if the answer is yes, then it wasn't a requirement. It was that simple. So, okay, question 2, I'll just jump to that. What is your opinion of requirements referring standards? Do we have guidance for these types of requirements? We tend to do it badly because we'll cite a whole standards document that has 1,500 requirements, and when the project budgets the project, they don't realize there's 1,500 requirements to address there. So my recommended process is you incorporate each and every requirement out of whatever standard is. There's no other way to avoid missing something. That also helps your acquirer see the costs they're levying on the project by simply calling out a whole standard, which may not be totally applicable. That's a lot of work, but you're either going to pay it up front or you're going to pay 10 times that downstream when you get to verification and they say, show us that you satisfied this standard, one requirement. It's a nightmare, and I bet you Lou has lots of horror stories about that. Okay, what else do you want to take in the time we don't have?
Yeah, do you have a couple more minutes to
Okay.
answer one more? Going from Jeffrey, I think, are system engineers seeing more of the informal requirements gathering and elicitation from stakeholders?
I don't know the answer to that. That's something that maybe you ought to poll the members of the working group and say, is it getting better or worse? It was never very good. I don't know if it's gotten better or getting worse. It just Agile has introduced a whole nother dimension. We don't need no stinking requirements. We're just doing Agile, right? You've probably heard that one. So,
Well, I think case in point is with AI, the false pretense of value and, requirements and how that's impacting the business is unclear, but they're marching
mm-hmm,
forward without requirements. They're just using these things called user stories,
mm-hmm.
which are it just seems like we're heading in the wrong direction.
Well, a user story can be a basis for having good requirements. In fact, the formalized user stories I remember learning when I was being taught about UML, all the data in there actually can be synthesized into a requirement.
If it's grounded in process, yes.
If it's a well-stated user story. If
Right.
it's just a notional thing with a cartoon on a diagram that, I want to be able to withdraw money. Okay, that's not a user story. That's a mission statement.
Hmm.
That's not a requirement that you can't write a requirement to that. It's not a complete user story. So you have to, if you're going to say user story, then you have to adopt the formalism of a user story and have all the essential elements of the user story. Precondition, postcondition, performance attribute, functionality, actor, et cetera, et cetera, et cetera. You can't,
UML.
you
Yep.
can't cheat.
That's right.
Yep,
That's right.
very
Yeah.
well stated.
Yeah.
Well, I think there was one more question in there, but I think we'll call it a meeting for now.
Okay.
So very much appreciate your time, Dr. Carson. Very interesting
Thank you.
topic.
Okay.
Um,
So if you're interested in working this project, contact the Lou or the other co-chairs and Kevin and let them know that you want to lead it and have at it. And if you have other questions that I didn't get to, you can send me an electronic mail and I'll be happy to respond or post a question to me on LinkedIn or whatever.
yep,
Yeah.
sounds very good. Thank
Okay, and
you.
I'll see you later today,
Yes, so
Kevin. Yeah.
very similar presentation later this afternoon.
Okay.
Thank you
Thanks,
all for your
everybody.
time. Bye.
Thank you. Bye.